Welcome, everyone, to the Cardano Effect Podcast, episode 23. The purpose of this podcast is to take high-level developer information and projects that are occurring within the Cardano space and break them down into bite-sized, consumable pieces of information for everyday use. I'm your host, Philippe, and let's get this podcast started. So our three hosts are with us today, Sebastian, Rick, and myself, and we have a very special guest who Rick will be introducing very shortly. We'll get right into the mix of things, a very short introduction today. We have a lot of questions from the community, and we want to try to get to all of them. So if you haven't liked, commented, subscribed on this channel, please do so. Please consider supporting this channel. We really appreciate it. Thanks for tuning in. I'd like to give a quick shout out to the podcast Français Cardano that just started from Quentin and Robin. So you can go check that out on their channel. I'll put the link below. And basically for all the French speakers out there, they started a podcast as well, which is wonderful to hear. So with that being said, I want to preface this by saying that none of what we say on this podcast is financial advice or should be taken as such. You are your best financial advisor, and if you don't think you are, you need to find someone who's qualified to do so. So with that being said, Rick, how are you doing today? What's going on?
Philippe, I'm doing great today, thanks. You know, it's springtime, early March now, so pretty nice here on the eastern side of the United States. And I'm also very glad to hear about the French language podcast, and it would be really nice to see other languages pick up on doing podcasts as well. I would like to make note to our viewers and listeners that this podcast is available on Google Play Music, iTunes, Spotify, and SoundCloud. And we have our Reddit channel is The Cardano Effect. That's where we collected our user inputs, the viewer inputs. And there was a lot of good questions on there today as well. And we also have the short takes on the Cardano Clips YouTube channel, which is starting to become pretty popular because the Cardano Clips have a question followed by the answer in the video. So those are very useful. So I would like to introduce our special guest today, and is Professor Aggelos Kiayias, Chief Scientist at IOHK. He has written many of the white papers that are used in Cardano. So Professor, how are you doing today, sir? And where are you calling in from?
I'm doing great. So thanks for having me on the show. And I'm here in Athens, actually, Greece today, and I'm joining in. Very excited to be on the show and tell you more about the work we're doing. I started working in cryptography about the mid-90s when I was a math student, actually. And as a matter of fact, here at the University of Athens, here is where I completed my math degree as an undergrad. So I became acquainted with cryptography. It was a very different time then in terms of what cryptography was about. But it's in many ways, it was exciting in similar ways that it is today. Much more theoretical, of course, at the time, and the questions were different. But surprisingly, many of the very nice questions that we are dealing today in the context of constructing blockchain protocols and distributed ledgers were discussed then. So issues like secure multi-party computation, distributing trust, etc., were at the cutting edge of crypto research at that time. Of course, things were quite raw, and many results were missing. So we've went a long way since that time, and it has been a fascinating ride, definitely for me, and I guess for other people that started then and earlier on. So, now about 20 years later, it's a fascinating ride, and it's actually very nice to see many of these results. And many of the problems that we were studying at the time were quite theoretical. It's very nice to see them actually being implemented and having people excited about this technology.
All right. I'm excited about the technology too. And it sounds like, so you were there for the birth of crypto long before Bitcoin even came about, many years beforehand. Was it mid-90s or late 90s you started?
Yeah, I was a math student, started in 1992 at the university. I became familiar with cryptography around that time. And then I was very fascinated by that. I wanted to do research, and crypto was really like a big excitement for me at the time. So I just went right ahead and started doing graduate research as a graduate student. That was like in 96. Then in 2002, I got my PhD, and then I continued doing research as an academic. So starting from 2002, is already like, a number of years that I'm working as an academic at universities and as a researcher in cryptography.
Thanks for giving us that introduction. We're going to move right into the Reddit questions, and some of them they may overlap. The questions may overlap. We want to know your story about how you got to IOHK, but I see that some of the questions have asked directly that statement. So we'll get to that when we get to that. But Rick, I'm going to start off with the first question, and then we can alternate. Sounds good?
Yeah, sure.
Okay, so our first question is from user Lettuce Chill, and his first question is, what are the findings from DLT and ZK snarks research? Any interesting ideas that can be integrated with Ouroboros? And what are some of the interesting things of these protocols? So this is a three-part question asking you about DLT and ZK snarks research and how that relates with Ouroboros.
Yeah, okay. So let me just take it from the ZK snarks. As DLT, I guess distributed ledger technology is a very broad concept. So I'm not sure actually what this might refer to. I mean, distributed ledger technology is a very broad umbrella term, but ZK snarks is something quite specific that we can get on right away. So ZK snarks is a very interesting cryptographic tool. It stands for Zero Knowledge Succinct Non-Interactive Arguments of Knowledge. So this sounds like a handful, but basically what it does is that it enables to communicate that a certain statement that is publicly known has a proper structure, and I know certain possibly private items or components of that statement. So these are a technology which belongs in a big tradition in cryptographic research that goes back many decades and has to do with zero knowledge proofs. So a ZK snark enables to create such a zero knowledge proof, so-called, in a way that is quite efficient to be stored. So the size of the proof itself is small, and then this is where the succinct or the S part in the snark comes from. So over the last few years, there have been a lot of developments in designing more efficient and performant ZK snarks, and it has been early on observed that they can be used in the context of blockchain protocols to perhaps potentially add them make them more private or make them more efficient. Now, in the context of Ouroboros, we have already seen a couple of examples where ZK snarks could be useful. Actually, we do have two works that are coming up in the upcoming IEEE Security and Privacy Conference that will be in California in May 2019. In the first of these works, called Ouroboros Crypsinus, we are developing a version of the Ouroboros protocol that is privacy enhanced. So basically, if you want, very similar to Zcash for those viewers, for those listeners that are familiar with that protocol, it's possible to hide the transactions so that it's not possible by looking at the ledger to understand what is, let's say, the recipient of a specific payment. So we're developing a system where it's proof of stake, but at the same time, it is possible to have this privacy enhanced ledger. And this is done by applying as an application of ZK snarks. Another potential for ZK snarks is coming in another paper, which also is going to appear at the same conference. And this is the proof of stake sidechains, where we show that it's possible to use ZK snarks to create succinct proofs that a certain event took place in a blockchain, and then demonstrate that in a different blockchain. So this is the problem that refers to how is it possible to establish an event in one blockchain and then have another event take place in a target blockchain as an outcome. So this is something that enables things like peggings between blockchains, transferring assets between blockchains, and so forth. So there's plenty of nice applications about ZK snarks, and this would be something that we definitely have in the context of Ouroboros research. And there's like these two papers that, as an example, that show how we plan to use them in at least two different cases, for privacy and for interoperability between different blockchains.
So you mentioned Ouroboros Chronos. I have a follow-up question personally. You're mentioning privacy within the proof of stake protocol, Cardano, and Cardano wants to interoperate with the legacy system. So how do you balance privacy with truly being interoperable? Because large companies, large existing companies, you have the Facebooks, the Amazons, the Googles, they want to maintain a certain level of control. And that's just a broad example, but I'm sure smaller companies want to maintain a sense of control as well. Are there instances where companies can control how private their transactions can be? Or is there some sort of sliding scale?
Yeah. So I guess here the issue is that you can think of privacy at having at many different levels, and the question here is that there's always a trade-off. On the one hand, you definitely want to have privacy for a certain number of transactions. I mean, there is a lot of, for example, legal requirements that a company should conform to. For example, like in Europe, there is the GDPR regulation, and there are similar data privacy regulations everywhere in the world that a company that handles client data should be compliant with. So having protocols which are decentralized is clearly comes at a certain moment and clashes with privacy. The problem here is like just being decentralized means that you may have many different actors being active in maintaining, for example, a distributed ledger. And then the immediate question that arises is that what information potentially these actors should possess in order to perform the act of maintenance. So actually, this is in many cases a very interesting trade-off. And this is actually where some of these cryptographic techniques, for example, like ZK snarks, can be particularly useful. Many distributed ledger protocols, as they have right now, they have serious privacy leakages, so to speak. I mean, we can, for example, Bitcoin is a very good example of that, where basically there is a lot of information to be extracted by analyzing the Bitcoin blockchain, as numerous works have shown already. So it's very interesting to see to what degree it is possible to achieve decentralization and privacy at the same time. There is for example, Ouroboros Chronos is one of the examples of research that we've been doing recently towards that direction. But in general, I can say that this is one of the very interesting research directions right now for distributed ledgers, and one that I anticipate is going to be a lot of more work that needs to be invested on in the next 1 or 2 years.
Okay. Thanks for that answer. I appreciate that. So I'll move back to the Reddit question. Lettuce Chill had one more question and basically was asking, what is coming after Ouroboros Genesis?
So we have a new protocol that we completed recently. It's called Ouroboros Chronos and is building directly on the Ouroboros Genesis work. So Ouroboros Chronos is a new generation of the protocol that we're going to be publicly releasing in the next couple of months. The problem that we are tackling in Ouroboros Chronos is that has to do with the time information which is available to the participants. Now, if you look at proof of stake blockchain protocols like Ouroboros and others before that have been proposed, they use the time information that is available to the clients in a non-trivial way as a way to determine how do you extend the blockchain. So a very natural open question is whether it is possible to design a proof of stake blockchain protocol that has as little time dependency as possible. And when I say time dependency, I'm referring to access to what is the right time. Now, the problem here is that in a decentralized environment, having access to the right time might be a quite challenging target. How do you determine what is the current time? So the work that we've undertaken in the Ouroboros Chronos construction and proof of stake blockchain is that tries to eliminate the assumption for having access to a global clock and at the same time shows how is it possible to create a proof of stake based global clock that can be used as a global time reference point for other protocols that can be built on top of that. So this is basically achieved by having the nodes that participate in the protocol using a blockchain way for maintaining and adjusting a joint clock that we prove it can be assured that it is within a particular small time window. So in other words, it's not possible for an attacker to cause the nodes to become sort of desynchronized with that clock. So I'm very excited about this paper actually because it shows that we can have a much more resilient way to build a global clock protocol. And I anticipate also that such a type of work can have other applications in higher level protocols that would like to have access to a robust clock that could now be provided by the protocol. So here's an example. Let's say that you can have a blockchain protocol like the Ouroboros Chronos protocol providing clock services or timing services to protocols that are being built on top of it.
Well, that's pretty amazing because I've been working with time-sensitive applications for quite some time. And when you have time-sensitive applications, keeping the clocks synchronized has always been very important because if they go out of sync, then some nodes begin to fail or they don't respond correctly. So that's interesting that you're solving that problem. And one question to kind of piggyback on top of that question from Lettuce Chill, the various versions of Ouroboros Genesis, what's coming afterwards. Something I was curious about is like the next version of Ouroboros that we're going to is Ouroboros BFT, then Ouroboros Genesis, then eventually Chronos and Hydra. Do these different versions of Ouroboros, do they build upon each other as the new ones come out? Like, will Ouroboros Chronos, eventually when that comes out, will it contain properties from the previous versions of Ouroboros? Or is it a whole new implementation?
Yes, thanks for asking this because I understand there are people that, asking the question, how does the different versions of the protocol compare to each other? So basically what happens is that Chronos is building on top of Genesis. So you can think of Chronos as an extension of the Ouroboros Genesis protocol that provides this clock capability. Now, in the Ouroboros Genesis protocol, for instance, the clock was assumed. So it was possible, the protocol was described in a setting where the participants of the protocol had access to time. And now this is removed in the case of Ouroboros Chronos. But Ouroboros Chronos incorporates all the features that were present, let's say, in the Ouroboros Genesis protocol. So it's a protocol that basically built on top of that previous work. At the same time, maybe I can add to that, that there might be cases where you believe that you have access to goods to a global time. And in that case, you may not want to deploy Ouroboros Chronos because deploying Ouroboros Chronos, of course, means that there should be additional protocol logic that needs to be implemented. And even though there is not a significant footprint, still the protocol has to send additional messages that will facilitate the synchronization. So like in every case, we need to have a good understanding of the problem and the deployment setting that a certain blockchain protocol needs to operate, and then we can choose the right protocol. So basically what we're designing is that we're designing protocols that have the right set of features, but then in a specific deployment, there is a completely different thinking that goes into about what features are relevant. So now you can ask, we have Ouroboros Chronos, and then another question could be, for instance, in Cardano, what would be the right protocol to implement? Right? And these are two separate questions. The one is dealing about basic protocol design questions, and the other is asking about a specific application, what features of the protocol, of the Ouroboros protocols are relevant and have to be implemented.
I have a related question also. So in a lot of IOHK's communications leading up to Shelley, there's been mention about Ouroboros Genesis, but also of Prouse. And sometimes it's also called Prouse plus Genesis. So can you kind of clarify for our audience, what does IOHK mean when they say Shelley will be Prouse plus Genesis or the different wordings they've used in the past?
Yeah, so I guess this reflects the type of thinking I'm talking about. So we do have these protocols, Ouroboros Prouse, for instance, and Ouroboros Genesis. So Ouroboros Prouse dealt with two main issues. The first one was about these adaptive attacks. So it dealt with attacks that take advantage of information of the protocol execution, and they try to direct the attack adaptively based on that information. And it also dealt with issues of partial synchrony of networks that they are not operating in a synchronized fashion as in the case of the analysis of the Ouroboros protocol. So the first protocol. Now, going to the case of Genesis, we dealt with the problem of taking a client that would like to connect to the blockchain protocol, to the instance of the blockchain protocol that is running, and the client would like to connect to the right blockchain, so and not be confused, let's say, potentially by an attacker that would like to confuse the client and potentially connect to a wrong version of the distributed ledger. So when at IOHK we sometimes have referred to Prouse plus Genesis, is basically the process that says we have these features coming from Ouroboros Prouse and Ouroboros Genesis, and we have the threat model that we want to use in the case of Cardano, and we are using all these protocols features from these protocols to get the right protocol instantiation. Because I have to say, going from the paper to the actual fully parameterized implementation, there's still a lot of engineering work that is needed. And there's a lot of fine-tuning that is necessary. So basically, Prouse plus Genesis would actually mean here that we take these features and we suitably parameterize them for the application of particular deployment, let's say, in the context of the Cardano system.
So there could be multiple instances of Ouroboros running at the same time on the same blockchain. Is that possible?
No. Perhaps I didn't make myself clear on that. So what happens is that there is one Ouroboros protocol that actually uses these features which have been published as part of Ouroboros Prouse and Ouroboros Genesis. So it's essentially one protocol that shares characteristics with all these works. And you can think of it as the Ouroboros implementation for Cardano that is using features from Prouse, Genesis in this particular case.
Okay, thank you. I appreciate it. Okay, so our next question, thank you, Professor. Our next question is from RJM Coin, kind of on the same lines, the different flavors of Cardano and Ouroboros. And RJM Coin asks, can you tell us more about enterprise Cardano?
Yeah, so I guess like the relevant topic here to discuss is what do we learn from all these protocols about deploying protocols in the permissioned environment? And this is a quite broad question that we have explored and asked a number of times. Now, obviously, Cardano itself is a public blockchain, but it's very interesting to explore what do we learn from all these designs that we're doing for public blockchains, like the Ouroboros protocol, for the context of permissioned distributed ledgers. And permission distributed ledgers actually have a lot of applications, and this is something that is definitely within scope of our general investigation at IOHK, and most certainly, like from a research point of view, at IOHK Research. What we have right now is a new protocol that we call Ouroboros BFT. We published it last year. This is a version of the Ouroboros protocol which is aiming to answer the question, is it possible to get a simple, effective protocol for a Byzantine fault-tolerant scenario, a distributed ledger that is based on the Ouroboros design? And this is what we did there, and the protocol actually is very simple and something actually that I'm particularly happy about is that it demonstrates how is it possible to exploit basic ideas and concepts from blockchain design to and brings them to the space of classical Byzantine fault-tolerant protocols. And this is actually a protocol that we have implemented and is going to be used in a number of different occasions. Most certainly, actually, it's also going to be used within Cardano, as we're going to be using this as a transition protocol from the first implementation of the Ouroboros protocol that is running right now to in transition to the version of the protocol that is going to be running Shelley. So the Ouroboros BFT protocol is going to be used as this transition point, but we also have other plans for Ouroboros BFT in the context of permissioned ledgers, and we're going to be rolling them out later on.
Awesome. Thank you, Professor. And if any of the viewers have further questions about the transition, please see episode 20 with Professor Duncan Coutts, where he explains that transition process very thoroughly during that episode. So that's a good tie back to the previous episode. So, all right. So the next question, Philippe, are we ready for the next one? I'll finish up RGM coin and touch on Audi, and we'll go on from there.
Yes, sounds great.
All right. So the next question that comes from RGM coin is also asked by Audi 2053 on Reddit. Two people had the same question. The question is, do you have a reply to the Fly Client paper regarding criticism of NEPA-PAUS? And what I'll do is I'll read Audi 2053 has a more thorough description. So for the listeners who are not familiar with that paper, the Fly Client paper, Audi goes on to explain a recent Fly Client paper on SPV wallet suggested that NEPA-PAUS, and what they're referring to is Ethereum and Bitcoin here. They have a separate paper that's similar to one of the papers that Professor Kiayias had written. So what they go on to say is, it suggested that NEPA-PAUS can only be implemented in a proof-of-work blockchain with static block difficulty, i.e. not in the case of Bitcoin and almost all other proof-of-work chains. They don't have static block difficulty. Furthermore, it is suggested that the superblocks in NEPA-PAUS can be easily influenced by an adversary by bribing the miners to not publish the blocks with definite hashes. How true are those claims, and how could you defend it? If that's true, will the NEPA-PAUS work only on proof-of-stake chains? So I guess the question is there. I'm assuming you've seen the Fly paper from ePrint.
Yeah, of course, yeah.
Okay. Could you tell us a little bit more about it and about that paper and how it affects Cardano?
Sure. Okay, so let me start from the top. I guess talking about NEPA-PAUS. So NEPA-PAUS, or non-interactive proofs of work, is a cryptographic primitive. So what does that mean? Is one of the sort of objects that we study in cryptography, very similar, let's say, to or at the same level, if you want, with the ZK snark or non-interactive zero-knowledge proof, etc. So these are some of the objects that are interesting in cryptographic design. So NEPA-PAUS is actually a primitive that we introduced, and the reason that we introduced it is that the objective was: is it possible in a proof-of-work blockchain to create a proof about a certain predicate that happened in the chain that is adopted by the miners that are running a particular proof-of-work based blockchain? And is it possible to communicate that proof to a verifier in a way that the verifier will not have to have what sometimes in computer science is called complexity, or if you want, running time, to make it a bit simpler, that is proportional to the whole size of the blockchain that is to be verified. So a non-interactive proof of work is a particular instance of a proof of work. Proof of work is a primitive that was introduced in a previous paper that basically did exactly the same thing, but potentially interactively. And a non-interactive proof of work, or NEPA-PAUS, is a protocol or an algorithm, if you want, that enables a prover to demonstrate that a certain event happened in a blockchain that is maintained by a set of miners in a proof of work type of setting to a verifier, so that the verifier can verify that claim that the predicate took place efficiently, with running time again, which is like less than the blockchain that is observed, or the blockchain in question. So this is a very useful primitive, obviously, and you can immediately see that it has a lot of applications. For example, in the context of doing efficient payment verification, but you can also think of it as having applications in the context of minimizing the state that is required to be maintained by participants in the protocol, and so forth. So what we did in the paper where we were discussing NEPA POWs is that we introduced the primitive, but we also gave a construction. So this construction was detailed in our paper and was using this interlinked data structure. So basically, it was based on the fact that the blockchain that is used to construct these proofs has a certain structure. So overall, I think this is a great question. It's a great question from a cryptographic point of view. And I'm very, very happy that other people are working on improving constructions for NEPA POWs and basically light client design in general. Because this is how you can think about these questions, right? We pose questions for cryptographic design, and then we have constructions for them. So it's very nice that other people are working on the same problem. And Fly Client, in a sense, is another implementation of a NEPA POW. And I've seen the work, at least at the first reading, and I think it's worthwhile and it has good potential. Now, we had a number of open questions that left in the NEPA POW paper. And these questions had to do actually with some of the issues now you're pointing out. So these are open questions that were clearly stated in the paper. Like, we were working on static difficulty, and we were having as an open question whether it's possible to have a construction in variable difficulty, as well as we were having questions about how is it possible to make these NEPA POWs both succinct and secure. So it would be nice to see if these questions are solved. I haven't been able to verify that. There's a lot of technical details which unfortunately are missing right now from the published draft, but I think like the approach taken in Fly Client is very interesting, and I'm going to be waiting to see for a full version that has the full proofs. Needless to say, at the same time, we're also working on this question. So after publishing NEPA POWs and identifying all the issues, we continue to have work, and we have a lot of unpublished work currently in draft form, of which I'm hoping that we're going to be completing soon and publicizing. So in any case, I think like what's important to keep in mind here is that the importance of clear security models and having all accompanying proofs cannot be understated. So if you look at our papers, we never claim results without fully substantiating our claims with security proofs. And in general, like if you do cryptographic design, the construction itself is always developed together with a security proof. The reason for that is that there is an interplay always between the construction and the proof. So what happens actually in cryptographic design is that you identify a question, which is, for example, design a NEPA POW. And then you start developing a construction, and you develop the construction together with the security proof that the construction you have meets the objective. So in that particular case, NEPA POW is the objective. Then you have an algorithm, the construction, and then you have a security proof that the algorithm you have meets the objective. So what happens in cryptographic design is that the construction and the proof are developed together. The reason is that the construction itself very frequently has specific features that enable the proof to go through. So a construction without a security proof is rarely interesting or useful. And the reason for that is that you can never know for sure whether actually it solves the objective you have set. So this is something that I think there's a lot of research that's still required to be done. And I'm very excited that there is more people are working on this, because these are really interesting questions. And actually, this was also our hope that other people will be inspired to solve and work on the same questions, because I think these are some of the very interesting questions in the context of proof of work based blockchains.
Yes, I was glad to see that paper was published as well, because they actually referred to you in the abstract. And as I read the abstract, I realized, oh, they're doing very similar to NEPA POWs, but they're trying to improve it in some way. So the whole peer review and the open publishing of these papers, it's actually working. It's getting people talking and thinking and trying to have many different people solve these problems. So I thought that was pretty good.
Exactly, yeah, and this is exactly also, what we aspire by the work we do at IOHK. I mean, we actually do open research exactly to achieve that effect. We want our community to work as a whole and try to attack these problems. These are very interesting questions, and we still have a long way to go in order to find conclusive and good solutions for this basic cryptographic problems that arise in that context. So there's definitely promise for good constructions here, and but there's definitely more work needed. So we're still not there. Definitely not in terms of having a completely answered all the relevant questions here, which in this particular case is having a NEPA-POW construction that is fully and formally analyzed in a threat model that includes variable difficulty, which obviously, as the very astute Reddit users that you mentioned have identified, that definitely this is the question that is relevant in that setting. And I should say, I mean, this is also something that we had very, very clear in the NEPA-POW paper. This was one of the open questions that were left in that paper. And it's actually something that we have already quite a lot of work that is unpublished. But as I mentioned, like we are working always on the mode of having a full security proof together with a construction, and we're only going to have something out when we are confident that we have the full analysis available, so that the readers of our work will be able to have also the full justification and security claims about why our construction works and actually meets the objective.
I'm amazed by the progress and the process both. Philippe, would you like to take the next question there from Reddit user Audi2053? Lots of really good questions coming from that direction.
Yes, that sounds good. That sounds good. I just wanted to let everyone know that you can find the papers on the IOHK team portal website. I mean, the IOHK papers website. And Professor Kiayias has a lot of papers that are included in this stack. So if you want to check it out, go and download the paper and take a read for yourself. The NEPA-POW paper is there. And you can also check out, Sebastian did a multi-part series on YouTube discussing NEPA-POWs, which is great. So you can check that out as well. So the next question by Adi2053, and I also wanted to add that Professor Kiayias has over 5,100 citations on all of his papers, which is legendary. So the next question by Adi2053 is, will someone be able to implement private smart contracts on Cardano, or would private necessarily mean an entire different blockchain with privacy feature smart contracts connected as a Cardano sidechain?
Yeah, so I guess like the first thing to ask here is like, what exactly is a private smart contract? And privacy itself is a difficult notion to define. There's many different flavors of privacy and many different ways you can think about private smart contracts. So at a certain level, a certain type of privacy should be capable of to be obtained from what the Cardano computation layer already will be able to offer once it's fully operational. At the same time, there are notions of privacy that the basic computation layer will not be able to have it, and what we would need is an extension of that privacy model. For one thing, the logistics part itself is something that leaks a lot of privacy. And when I talk about logistics, I mean the accounts that you see in the ledger, the UTXO set, all the information that you can extract by observing how tokens are moved from one account to the next, or from one address to the next. So we're definitely very actively working on IOHK research about solving these questions. And I cannot say something right now in terms of what's going to happen, but I can definitely see possibilities here for having side chains within the Cardano ecosystem that offer some type of privacy-enhanced smart contract functionality. This capability might be together also with a proof of stake privacy, like the one that I mentioned earlier with Ouroboros Chronos. So there's a lot of possibilities here, and a lot of that I also do hope that is going to be community driven. So we have to see what the community of Cardano wants, and then accordingly things could be implemented. The one thing I can say for sure is that we do the research and we try to understand exactly what is needed. Then when the community is ready, we will have the options there, and it will be possible to move the Cardano ecosystem towards the right direction.
The last one from Reddit user Audi, I think that was already kind of covered. It's very specific. Assuming that the Nepal paper is flawless and works as assumed, it's not flawless. Professor already put that out. So we'll go to the next question from Y. Petrov. But thank you for those questions, Audi 2053. Fantastic stuff. So Y. Petrov asks, how well is Cardano secured? A very general question there.
Yeah, well, I mean, this has to do with the whole, task of taking like a very complex protocols, like the proof of stake blockchain protocols, like Ouroboros, and taking it down to a production-ready engineering solution. So there's a lot of effort done at IOHK with that. Now, from my point of view, what I make sure is that we work with the engineering team as a very tightly coupled team, and we are in very, very close collaboration at every step of the process to make sure that actually what is being coded and what is being implemented is something that aligns with what is formally analyzed in the Ouroboros papers. The same is the case for many of the other processes that are connected to the Cardano system, like the wallet and so forth. So there's a lot of effort put there to make sure that the system is secure, and certainly this is like our primary consideration. In general, I would say this is one of the most fascinating aspects of our work, taking basic protocols and designs and making sure that the way that they are engineered conforms to their security specifications. So there's a lot of effort in that, and at the same time, there is effort on making this process as transparent as possible. So this is something also that we're putting a lot of effort on publicizing the way we work. For example, there are formal specifications for the implementations. There is a lot of work that is put to document that and make it publicly available. So this is basically one of the most exciting aspects of the work we do at IOHK. And certainly, I hope that this is something that the community enjoys and seeing it as it unravels.
Thank you, Professor. And I think that addresses all aspects of those questions. But there is one part where it says, are there any plans to implement untraceable features in Cardano? I'm not sure what untraceable features are, because a blockchain is by definition traceable. But do you have any comments on that? Implementing untraceable features? I'm not sure what the definition is.
Yeah, so I would assume that this probably refers to privacy-enhanced transactions, like, for example, the ones that we discussed in the context of Ouroboros Chronos. And I would say there's definitely a possibility of having a sidechain that enables such untraceable or privacy-enhanced transactions. So it's not possible by looking at the ledger to see how assets are moving between addresses. And this is something that I see as a possibility as a sidechain. As I mentioned before, Cardano is a community project, and we're doing the research. But at some point, like, the direction of where Cardano is going to go is the right direction for Cardano, is where the community wants to take it. And if the community of Cardano wants a higher level of confidentiality in transactions, it's certainly a direction that the Cardano project will go.
Thank you for that. All right, and so that covers Y. Petrov. Thank you very much for those questions, Y. Petrov. Philippe, you got the next one?
Yes. So the next Reddit user is Mystical Writer, and this person asked, what is your view on quantum computers and how do they affect industry and cryptocurrencies? How well prepared is industry in general, and how does Cardano manage the challenge of quantum computers in the future?
Yeah, so there's a lot of research in designing quantum computers. I mean, it's one of these technologies that, a lot of times you hear is like it's maybe like a decade away or maybe coming up. I mean, for one thing, I have to say that thinking about the possibility of having quantum computers is a very critical one from a security point of view. And it is definitely possible and conceivable to have classical cryptographic algorithms that are quantum secure, that basically a quantum computer is incapable of solving. And it is definitely within our scope to study them. Actually, within the context of the research we're doing, we are looking into having post-quantum secure versions of proof of stake as well as proof of work-based protocols. This is something that we're actively doing research on. And this is definitely something. It was definitely some of the features that we're also going to be working on for Cardano. How to make the Cardano ecosystem post-quantum secure, using again classical algorithms, right, and classical tools.
That sounds good. That sounds good. One thing that I like about Cardano, they're always trying to future-proof their system. So if that comes to fruition within the next decade or 20 years, Cardano will be one of the cryptocurrencies that stands against it and is able to protect users' funds and secure the network. So that's wonderful. That's wonderful. Rick, did you want to move on to the next Reddit question?
Yeah, sure. Thanks, Philippe. And also, in relation to the last question, I had asked Sebastian before we talked offline about quantum computers and how they affect cryptography. And so for the viewers out there, basically, quantum computers happen to be really good at solving the kind of cryptography that is currently used. And that's why they're working on the quantum resistant versions, because the quantum computers happen to be good at solving that problem. So the next Reddit question comes from Reddit user Panzerline. And Panzerline asks, he says, if I'm not mistaken, EU grants do fund blockchain research. Beyond core funding, are there any EU grant schemes allocated to tackle specific problems where DLT, where they refer to the distributed ledger technology? So is there money allocated to tackle specific schemes for distributed ledger technology is expected to provide interesting solutions, proof of concept grants, translation programs, etc.? And for which problems?
Yeah, so EU funding and in general government funding is very much, in many cases, very much in line for doing work in distributed ledgers. There is a wide recognition that distributed ledgers may be able to provide better government services, for instance. And there is also like a quite wide recognition of the fact that distributed ledger technology can be quite powerful in transforming in general internet information technology. So there's a lot of government funding for blockchain research, and actually certainly some of the research we do even at IOHK research is government funded. So for example, IOHK research is a member of the Privilege Consortium, which is a European-wide Horizon 2020 project. And some of the questions that we are tackling, let's say, in the context of that project is how is it possible in a decentralized environment to do effectively software updates, which is a very interesting question because obviously doing software updates is a very critical operation, at the same time can be quite challenging for any decentralized system. So, and this is just one example of how, let's say, an EU grant now is funding some of the fundamental questions in the context of blockchain protocols. So, but there's certainly a lot of other opportunities, and this is certainly something that is of interest for the blockchain space in general. There's definitely like government funding for good research in the space. And I think like there's going to be more of it in the coming years.
All right, thank you for that. And yes, having government funding is a good thing because the government has a lot of interest in blockchain technology and how it affects the use of computers in general. Okay, so our last set of questions comes from Aggelos, from our Reddit user there. We're going to answer the questions from their list, questions 1, 2, and 4. So starting off with number 1, Professor Aggelos Kiayias, how did you meet the IOHK team?
Okay, so we met a bit more than 3 years ago, I think. I joined IOHK about that time. I met Charles. We realized that we both wanted to solve proof of stake, and I guess now the rest is history. Like, after that time, we had a very good alignment with what we thought was important. The approach that we had, that we were trying to follow, was a very good match, and I guess the rest now is what happened afterwards, which was a lot of work to get these things going and deliver these protocols, and hopefully much more to come.
Awesome. Second question: what is your typical day at IOHK? What does it look like?
Well, a typical day at IOHK in general, and I would say IOHK research, is it has to do with a lot of work and meetings with other people that's doing research. From my point of view, is a lot of management and context switching. This is also my typical day in general, because at the university, as a professor, chair in cybersecurity and privacy, I have to do a lot of management also in terms of younger researchers, a lot of direction setting, a lot of reviewing, a lot of proposal preparation, a lot of organization. Same thing at IOHK, where I have to manage our researchers on all the different research streams that IOHK is undertaking. So from my point of view, it's a lot of context switching. From the point of view of the researchers, it's a lot of hard work. That has to do with pursuing like all the solutions and the designs that we are trying to do at any given time, and there's plenty of them. At the same time, I'm an active researcher. Management is only something I do out of necessity, but I do like to so to speak, get my hands dirty, and I always try to sneak a little bit of time to write a few equations on a piece of paper. Sometimes I have to do it in the most improbable places, but in the most improbable times. But this is how it is. So in general, like it's pretty exciting, and it's actually the average day of someone that's doing full-time research and at the same time tries to manage other people doing research and doing that in the most efficient way possible.
Wow, it sounds like you have a very busy day. So we're going to get to our very last question. And this was from Aggelos. And the question is, what are your favorite books?
Oh boy. All right. So well, I have to think so I guess like I have many that, there are books that are quite inspiring over time. I mean, if I start, I mean, and I would just say in terms of literature, I don't want to go into technical or let's say non-fiction, but let me just give you a couple of examples of books I really enjoyed over time. I mean, I love Dostoevsky, and Brothers Karamazov was one of the really great books that were ever written. Lord of the Flies by William Golding is wonderful. I enjoyed a lot Catch-22 by Joseph Heller. That's a great read, and it's a lot of fun, and it tells you a lot about life. And finally, I think I should also mention, like, being Greek, and I would say my favorite Greek writer is Nikos Kazantzakis, and I strongly recommend people that would like to get familiar with one of the great writers that is in the non-English language should check him and read some of his books. He's really great.
Wow, thanks for that, Professor, and I appreciate you being on the program today.
Yes, thank you, Professor Kiayias. So we're going to wrap this episode up. We are over our time, and we have other obligations right now. So this was great. Professor Kiayias, you're always welcome on the Cardano Effect podcast whenever you'd like. I'm assuming that you'll be in Miami later next month. And once again, thank you for your time. We really appreciate you. The floor is yours. If not, we'll just say goodbye to our audience. Are there any last words that you have?
No, thank you very much for having me on the program. It was great to be here, and I'm going to be definitely in Miami. So looking forward to seeing all your listeners that might be there or might be tuning in to see some of the work we're doing when we're there. It's going to be a great event. So very much looking forward to that. Thanks, guys.
Perfect. Thanks, everyone. Until the next time. Bye.
Bye-bye.
you.